Now, let's consider this function. So we take f of x to be 1 minus the square root of 1 minus x squared. The question is f continuous on the interval I, which is minus 1, 1. So that's our problem. We have to see whether this function is continuous on this interval. Okay. Like we said before, the continuity of the given interval means for any element of the interval we pick, our function is continuous there. And so we are going to do this to check. Look. This. For any a such that minus 1 is strictly less than a and it is less than 1. Here now means I'm taking a from this interval, but then I'm not considering the end point yet. Right? So let's see what happens. If this is true, who is f of a? Our f of a is nothing but 1 minus the square root of 1 minus a squared. That is what we shall get if we evaluate f at the point a, where a lies in this interval. Alright. Who is the limit of f at x as x approaches a? Whether x approaches a from the left or from the right, we see that this is going to give us the limit as x approaches a of the function 1 minus the square root of 1 minus x squared. If you remember the rules of limit we studied before, just say a few that we need here. We know that the limit of f of x plus or minus g of x as x tends to a certain number a is the same thing as the limit of f of x plus or minus the limit of g of x as x tends to a as x tends to a. We're in that situation here. I can take the function f of x equal 1 is a constant function. I can take another function f g of x is square root of 1 minus x squared. It is still again another function. Then even inside the g of x, I can still rewrite it as function of another function. And so at the end of the day, we can pass this limit inside here, inside there, just by following the laws of limit that we already know. And if we pass the limit, so this is going to give me the limit as x tends to a of 1 minus the limit as x tends to a of square root of 1 minus x squared. I can still pass this limit inside, and when I do, everything here will contribute. Of course, as x tends to a, 1 is a constant, it is independent of a, so this limit is exactly 1. So this is going to give me 1 minus, if I take this limit as x tends to a, this is going to give me the square root of 1 minus a squared. Therefore, the limit as x tends to a of f of x is 1 minus square root of 1 minus a squared. F of a is also 1 minus the square root of 1 minus a squared. So the two of them are equal. So according to that definition, this function is continuous for every element a between minus 1 and 1. Now, don't forget that the question says, is f continuous on the whole of this interval? We have seen that it is continuous inside the interval, in the interior of the interval. What happens at the end points? So we shall also consider what happens at minus 1 and what happens at the point 1. Don't be lost We have already defined what we mean by limit of functions at endpoints of an interval. So we simply make use of that definition to investigate whether the function is continuous at -1, and also investigate whether it is continuous at the point 1. And that's the next thing we shall do. Let me just get space. So, at the point x equal -1, so we look at, so in this case now, our a is -1. So we're considering limit as of f at x as x tends to -1. If you look, our I is this interval, -1, 1. So we can only consider what is happening at -1 for all x greater than -1. That means from the right. Because from the left, f is not defined beyond -1. So we shall not be talking about the left-hand limit when we are considering the endpoint -1. In the same way, we cannot consider the right-hand limit when we are considering the endpoint 1. We can only consider the left-hand limit because beyond 1, this interval has no meaning again. And so, this is nothing but limit. So here, the only thing I can do is I put clause here. And so I have limit, that means we are looking at limit as x tends to -1 with x strictly greater than -1 of f of x. These two things I wrote here simply means I'm considering the limit from the right hand side. That means I'm considering all those x greater than -1. So I'm looking at all these people. And so this is nothing but again limit as x tends to -1 with x greater than -1 of 1 minus the square root of 1 minus x squared. And then this of course gives us nothing but 1 minus the square root of 1 minus -1 squared. And then this is nothing but tell me, this is 1, this is 0, square root of 0 is 0, so this is 1. So we simply get 1 as the limit. Now, who is f of a? This is f of -1. But then, by definition, this is 1 minus the square root of 1 minus -1 squared. And this will generate 1 again. And so, since the right-hand limit of this function at the point -1 is equal to f of -1, we conclude that, so our conclusion is that f is continuous. To the right at at a equal -1. In the same way, we're going to see again that f is continuous to the left at the point a equal 1. So we have continuity on the whole of the interval I. That is how to deal with continuity of a function on a given interval. All right.